Thank you. Again, I'm Andrea Pedroncini. I'm responsible of the Marine Department at DHI Italy. DHI is a global organization with a head office in Denmark and offices in more than 30 countries with more than 1,000 employees worldwide. So actually I can anticipate that we are global intermediate users of Copernicus products. Our areas of expertise cover the entire world of water, so not only marine waters, but also inland waters, urban waters, and groundwater, and so on. DHI is an independent organization. It's a private organization, but no owners, so we are not for profit. Every year we reinvest all our profit into our organization. I will illustrate a case study in dealing the port of La Spezia, so where we are now. This study has been commissioned by the Port Authority of La Spezia, and it deals with the dispersion and modeling the dispersion and fate of fine sediment plume during dredging operations in a specific area of La Spezia harbor. You know where we are now. The yellow box shows that we are between Liguria and the Tuscany. Here is the La Spezia Bay, which is partially enclosed by a dam, which is out of the yellow box here. And the study case is related to dredging operations at a specific part of La Spezia harbor, the so-called Molo Garibaldi, which you can see highlighted in yellow in the slide. Actually, this case study is a downscaling application from the Ligurian Sea model, which is already a downscaling of Copernicus product. Tania from ARPAL before already illustrated this slide. So we every day at ARPAL premises collect boundary conditions from the Med-Sea product, and they use their own atmospheric model. High resolution is a limited area model called Moloch, and they also add some freshwater supply from their hydrological model. And every day we have, and they have, this higher resolution circulation, salinity and temperature over the Ligurian Sea, and at a higher resolution in the area of the central Liguria region between Genoa and Sestri Levante. What we did is for a certain period, so it's not an operational system, it's an offline application of 45 days of dredging operations between February the 1st and March the 15th, 2015. So we took the boundary condition from the Ligurian Sea model, and we further downscaled the circulation model. This is the model domain, so it covers not only the La Spezia Bay, but also a larger area to properly capture the circulation in the area of interest. The resolution goes up to 50 meters in the La Spezia Bay. As you can see here, 50 meters is has been considered and tested as a proper resolution to capture the variability of bathymetry inside the port area, the bay, and also the morphology of the coastline. What we added, why a downscaling is needed in similar case? Because not only due to the resolution, to the higher resolution, so to be able to capture the circulation at with higher accuracy, but also because there are some freshwater supply inside the domain which can affect the dispersion dynamics inside the port. And I refer to basically two freshwater supply. One is the Magra River, which is a river between Liguria and Tuscany. This river, when during winter and autumn, can have significant discharges. You can see below the time series of water discharges in the simulated period. So we have peaks of more than 600 cubic meters per second, and this river is not included, of course, at the large scale of Med Sea level, of course, but and it is included only climatologically in the Ligurian Sea model. So we used real data for our application. In addition, we also included the discharge from a power plant, which is located inside the port. This power plant has a variable freshwater supply of around 15 cubic meters per second, with a delta of difference of temperature between the water released and the water temperature of the recipient water body of plus 5 degrees. So this also affects the stratification of the thermal stratification of the bay and the density inside the bay. Also the circulation. This is an example of the circulation of our downscaled model. You can appreciate here, for instance, the circulation between the islands in front of Porto Venere, Palmaria Island and Tino Island. Of course, this is possible only with a higher resolution and downscaled products. But our focus is, of course, in the bay, inside the bay, and we of course captured the typical 3D circulation which occurs in this bay, with fluxes of opposite direction at surface and at the bottom at the two openings of this bay. I can skip the animation of temperature inside the bay, and I will go through the dispersion application, the sediment dispersion application. The aim was to understand the fate and dispersion of dredging sediment released during dredging operations. So we collected, of course, detailed information from the Port Authority of the operations. So when, how much it was dredged, and how long the operation, each dredging session could last. Dredging operations have been always operated with the help of turbidity curtains in place. So what we assessed is a typical situation of failure of these turbidity curtains, which could happen, and on the other hand, the case without turbidity curtains. So what would happen if turbidity curtains would not be there, and if turbidity curtains would collapse immediately? Of course, we collected also data of sediment from the sediment characterization made by ISPRA. We divided the sediment into three fractions of different size, from medium silt to fine silt and sand, and we made assumption of a release in the water column of 5% of the dredged amount, or 10% of dredged amount, which is a large amount of sediment, which is far more than we usually have during dredging operations. And this is an example of results over the entire period. We located the dredging source, the sediment source, exactly at the same time and with the same amount of dredged material around Ravano, Molo Ravano. This is the case without turbidity curtains, which is not real. In reality, it is not happened like this, but this is the result without, in the assumption of no turbidity curtains in place. And this is the map at the end of the period, 45 days, of the deposition in millimeters of settled material. Of course, the aim of this case study, of this project, was to assess the behavior of suspended sediment concentration at certain location of interest. One is around the dredging operations area here, and we of course can see the variability of suspended sediment concentration depending on the time of operations, but also on the hydrodynamic conditions, and also in the vicinity of the dam where important mussel farms are present. And here is an example of the behavior of the time series of turbidity coming from dredging operations during the 45 days. You can see that we are up to with peaks of 40-50 milligrams per liter in the vicinity of the dredging operations area, and we are always less than 1 milligram per liter at a distance which is more or less 2 kilometers, 2-3 kilometers from the operations area. So in conclusion, and I also take the opportunity to link out my presentation with the presentation from ARPAL. CMEMS products and services are already feeding the Ligurian Sea modeling chains and many applications within Ligurian Sea. And of course, as I demonstrated, downscaling is needed in many cases to address coastal applications and water quality applications, also for our Ligurian Sea Environmental Agency. Some bullets for possible discussion. One is the foreseen, the expected availability of heat fluxes and also maybe for surface winds, which can extend the use of the products. Because so far, of course, we need to have also a link with an atmospheric model to do a proper downscaling, which is not always the case. So if we have some additional information from typical atmospheric modeling outputs, of course, we can extend also in other locations where a limited area model, atmospheric model, is not maybe available, the use of downscaling. And then as a proposition, of course, if possible, higher resolution of the core service product would be, of course, more than welcome. And in some cases, maybe not this case, but in other cases with more shallow water, the introduction of tide in the Med Sea product could be, of course, of great help. And I have concluded my presentation. Thank you very much.